Question number 28, a very, very straightforward and a simple question. Indeed, this sort of question really helps you to pep you up psychologically in the examination hall. So they have their own significance. What does the question say? It is in fact derived from kinetic theory of gas. It says that a rigid diatomic ideal gas undergoes an adiabatic process at room temperature. The relation between temperature and volume for this process is Tv raised to the power x is constant, and you need to calculate x. So here, if it is an adiabatic process, so that's going to be Tv gamma minus 1 is constant. Gamma being 7/5 for diatomic, so gamma minus 1 is going to be Tv raised to the power 2/5 is constant, and this thing is x. So x would be option number 1, which comes out to be the correct option for question number 28. Now it's time for the second last question of this shift. Question number 29 has been brought from calorimetry, and it's something like this, that ice at minus 20 degrees centigrade is added to 50 gram of water at 40 degrees centigrade, and when the temperature of the mixture reaches 0 degrees centigrade, it is found that 20 gram of ice is still unmelted. In other words, the final mixture is at 0 degrees centigrade obviously, but there is a certain portion of ice which has not melted. In other words, it's an equilibrium of water and ice at 0 degree. So it says, say, 20 gram of ice is still unmelted, and we need to calculate the amount of ice added to the water. Now, you can go in this way. Normally in calorimetry, we are used to with going into the calorie unit. Like this can be said as 1 calorie per gram per degree centigrade, and this is of course 1/2 calorie per gram per degree centigrade, and this comes out to be 80 calorie per gram. But if you wish, then of course you can do it in the regular SI unit as well, but I would like to prefer to go through the calorie unit. So let's say first of all, the 50 gram water has come from 40 degree to 0 degree. So 50 into C of water is 1, and 40 degree to 0 degree, so that comes out to be 40. So mc delta theta, that's the heat released by water when it comes to 0 degree. And next side, let's say that 20 gram of ice is still unmelted. Let's just assume that initially there was x gram of ice. So that will be x, C is half, and delta theta, that is 20. Now this is the heat absorbed by ice when it comes from minus 20 to 0 degree. And after that, 20 gram is still unmelted. In other words, x minus 20 has certainly melted. So look at the right side. This one is x gram of ice has come from minus 20 to 0, and this remaining has converted into water, consuming latent heat. And this is water when it comes from 40 degree to 0 degree, and that has to be equal for the simple reason heat released by one has to be heat absorbed by other. And you solve it, the value of x will be 40 gram. So option number 2 is going to be the correct option for question number 29. Now it's time to move for the last question of this shift. Let's see the 30th and the last question, and it has been drawn upon from modern physics. And the question says something like this: the Debye wavelength of an electron is equal to 10 raised to the power minus 3 times the wavelength of a photon of frequency this much. A bit of twisted, but very, very minute. So it's something like this, say, the Debye wavelength, if I call that as lambda, is 10 raised to the power minus 3 times the wavelength of a photon whose frequency is this much. So that will be into 3 into 10 raised to the power 8 divided by 6 into 10 raised to the power 14. So you need to understand that this thing is the wavelength of a photon, and the question says the de Broglie wavelength is 10 raised to the power minus 3 times the wavelength of the photon. And if this is the de Broglie wavelength, this can very easily be equated to h upon mv. So rest would be a simple calculation, and you calculate it, you're going to get option number 2 as the correct option for question number 30. So this is all from our side, the discussion of question JEE Main that was conducted on 11th January, and we discussed the question paper of the morning shift. We will soon meet in the next session where we'll be discussing the question paper of evening shift. But for those who happen to give this paper, I wish all the best for this paper and all those upcoming exams in the future. Thanks for watching. Thank you very much.